detail. I'm going to show you how it happens. Okay, so it says place about 10 drops of 0.1.
Can you please give us a wrap? Or you test your wrap, please?
So it's going to say, it says place about 10 drops of 0.1 mole per decimeter cube barium chloride in a clean test tube. Okay, so here's my test tube. Okay, and here is my barium chloride. Here. Yeah, here's my barium chloride. Okay, so I'm going to place 10 drops approximately into the test tube, and then I'm going to add sodium hydroxide to it as well. Okay, and then we're going to observe and see what happens.
Shall we check with them to see if they can see or?
No, they should be able to see. 4, 5, 6, 7, 8, 9, 10. Okay. And then 10 drops of sodium hydroxide solution. So my sodium hydroxide is here. Okay, notice how I'm just using one pipette. I don't want to contaminate the solutions. Okay. So again, the same thing, 10 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, then it says continue to add this dropwise, gently shaking until sodium hydroxide is in excess. And already you can see that there's a colour change happening. Okay, I'm trying to move it closer so you can see that. Okay, and there's a precipitate that's being formed that you should be able to see. Okay, so essentially that is the first sort of reaction. Okay, and you can see that there's a colour change that has occurred. Okay, it's gone to a sort of white precipitate and it's a solid that's being formed. Okay, right.
Leave it in the bottle, sir.
Leave it in the bottle?
The pipette, leave it in the bottle. Because you'll need it again.
Yeah, that's fine. Right, so that's the first one done. Now I'm going to repeat the same thing, the same process, but I'm going to repeat it with calcium bromide, magnesium chloride and strontium chloride. Okay, if you guys can't see or anything, just give us a message in the chat. Okay, and then we can try and sort it out for you. But it should be we'll be able to see. Right, so calcium bromide. Okay, same thing. Going to get a test tube. Okay, 10 drops.
Leave it together with the lid this time.
Okay. 10 drops. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And again, 10 drops of sodium hydroxide, approximately. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, then we're going to continue to add it drop-wise, okay, until it has completely reacted, until the sodium hydroxide is in excess. Okay, so again, again you can see there's a colour change, okay, and it's gone to a cloudy white precipitate, okay, once again. So make sure you're writing these down, these tests down into your lab books, okay, where it has the table. If it hasn't got a table, then just make your own. Next, we're going to go for magnesium chloride.
Middle.
Magnesium chloride, same thing, okay. 10 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 10 drops of sodium hydroxide. 2, 3, 4, 5, 6, 7, 8, 10. Okay, 10, but then I'm going to add a few more to make sure it's in excess. Just a few drops. Okay. And again, you can see this one, still a bit of a colour change, but not so much. Okay, not so much. And then the final one is strontium chloride. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then the same thing here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But then add a few more for drop wise in excess. Okay. And again, you can see this one, okay, also cloudy. Okay. Right, that's the first 4. Okay. Next, we're going to do the same thing, okay, but with sulfuric acid now instead of sodium hydroxide. Okay, so the same 4 compounds. Okay, it's calcium bromide, magnesium chloride, strontium chloride, and barium chloride. But this time, reacting them with sulfuric acid instead. Right, so barium chloride we'll start off with. Okay, again, 10 drops. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 10. Okay, and then sulfuric acid. Again, 10 drops. Okay, and again, I'm going to add it until the sulfuric acid is in excess. So already straight away, you can see from the first few drops that's already changed compared to the sodium hydroxide. Okay. So that was barium chloride with sulfuric acid, and you know that makes barium sulfate, which is insoluble. Okay, hence why it's so cloudy straight away. Right. Next, we'll go for calcium bromide. Okay, 10 drops again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And sulfuric acid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's 10. I'm going to add a few more, drop it in excess. Okay, this time barely any change. Okay, what was that? The calcium
What
bromide.
is that?
Calcium bromide. Okay, so barely any change here.
It is slightly, I think calcium sulfate is slightly
Yeah,
soluble.
slightly, but yeah, not much. Okay, next we'll go for magnesium chloride with sulfuric acid, which is going to produce magnesium sulfate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Which is soluble.
Yeah. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so you should remember the group 2 in terms of solubility. You should remember the pattern that it goes down. We did this in AS. Okay, so you should know why this is happening. So that was for magnesium sulfate. Okay, again very soluble, so no sort of precipitate. And then the final one, strontium. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then with sulfuric acid, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then add a few more so it's in excess. I can see it as I'm adding the drops, it's becoming a bit more insoluble and what precipitate is forming. Again, you should know the group 2, okay, the pattern of group 2. Okay, and you can see that that's gone white. Okay, so that's the group 2 tests. Okay. We're going to go on to another test in a moment. Okay. So just give us a minute to sort of set this up. Okay. Okay. So when we go through it, it should also be in your lab books anyway. When we go through it, try to remember the steps as much as you can, and try to think about how we can sort of maybe reduce error although there's not many ways of reducing error in these experiments. Right, so we're going to start off with, again, a test tube. Okay, I'm going to put 10 drops of ammonium chloride, okay, into a clean test tube. So I'm going to pipette 10 drops. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and I'm going to add 10 drops of sodium hydroxide solution. That's all right.
Can you please bring me some pipettes?
Right, so sodium hydroxide solution. Okay, 10 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Right. Then it says warm the mixture in the test tube gently using a water bath. Okay. So we're going to use boiled water. Okay. So I'm going to place the boiled water in this beaker and place the test tube inside the beaker. Okay. So we've already heated some water in the kettle. Okay. So add the water to the kettle. Sorry, water to the beaker. Okay, and then we're going to place the test tube, okay, inside, and then we're going to see what happens. Right, then the next step, it says, okay, is to get some damp red litmus paper. So I've got some litmus paper here. I'm just going to dampen it a little with some distilled water, and I'm going to place it over the mouth of the test tube, and I want you to know what happens. Okay, I'm just going to hold it over the mouth of the test tube, so there should be a gas sort of evolving, and you should know which gas it is. Yeah, I can see it, there's just the fumes, and I can see the colour change. You should be also be able to see the litmus paper sort of beginning to change colour. You should know the test for this gas from GCSE, and also for A-level as well. Yep. Okay, so this is a test, if you didn't know, it's a test for chlorine gas. Okay, turning damp red litmus paper blue, and you can see there how it started off red and now it's turned into blue, which means that when we did this reaction, chlorine gas is given off. Okay. Right, the other thing that I forgot to mention last time is the way in which we dispose of these. Okay, so now I've done this experiment. Okay, it's going to go into the disposable beaker, a larger beaker basically, and you just you don't pour the solution out, you can just put it in there as a test tube. Okay, and that's how we essentially dispose of it.
It's okay, don't worry, sir.
Okay, cool. Right, that was test 3. Okay, now test 4, okay, is testing for hydroxide ions in aqueous solution. So the test 3 was testing for ammonium ions. Okay, test 4 is testing for hydroxide ions. So we're going to take 1 centimeter cubed of 0.4 sodium hydroxide solution, okay, and put it in a test tube with red litmus paper, okay, or universal indicator paper, similar kind of thing. Okay, so there's my red litmus paper. And my sodium hydroxide, about 1 centimeter cubed. So probably around the same, around 10 drops. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, then it says record your observations. Okay, so you can see that it was red initially, and again it's gone to a blue colour. Okay, so it's gone from red to blue. Okay, then it says dispose of the test tube contents, so put it in the disposable beaker, same as before. Okay. And then it says take 5 drops of ammonia solution, okay, and place a filter paper and place inside with a petri dish. Because this one you don't need a test tube, you need to do it inside a petri dish. Okay. So filter paper. I'm just going to take one out. Okay. And ammonia solution, 5 drops, okay. 5 drops in the petri dish, and I'll put the filter paper on the petri dish with a lid. 1, 2, 3, 4, 5. Okay, then with a lid. Right, then it says dampen a red litmus paper with deionized water and place on the other side of the petri dish. And then replace the lid and observe for a few minutes. Okay, then I'm going to open this up. I'm going to place it inside. And already, you can see that it's already becoming blue. I'm trying to drop it. Right, so it started at red again, and it's already becoming blue, even though I put it slightly further away from the ammonia solution. Okay, so you can see that that's what's happened there. So again, that's testing for hydroxide ions in aqueous solution. Okay. Right, that was test 4. And again, the last step is just to record your observation and then dispose of it in the same way as we disposed of it before. Okay, so you don't want to pour these solutions down the sink. That's not what we're doing. We're putting them into a sort of waste bucket or a disposable beaker. Okay, if you can't see or haven't seen any of these, it's fine. It's being recorded as well, and the recording will be shared with you as well. So don't worry too much if you haven't been able to see properly. Okay, it's the first time we're trialing this in terms of virtual practical, so don't worry too much. Okay, we're going to pause again for a second to maybe set up practical 5 and 6. We'll see in terms of how we're doing on time. If not, then we'll stop at 4 and we'll continue with it next lesson. Right, okay guys, can you just make sure you muted yourselves, even if you just joined in? Yeah, just make sure you've muted yourself. I think that's you, Livson, so just make sure you're muted. Livson, mute yourself. Right, okay, so we're going to do test 5, okay, testing for carbonate ions, okay. So this is including lime water, so you would have known this test from probably GCSE, should know it from GCSE as well. So we're going to start off with lime water, okay, 2 centimeters cubed in a test tube, okay. So 1, 2, I'm going to do it by drops. I'm going to do approximately 2 centimeters cubed. Okay, so I have that ready in a test tube holder. Okay, now I'm going to sort of react together sodium carbonate and hydrochloric acid. Okay, and I'm going to stopper it after, and then I'm going to place the delivery tube into the lime water, and we should see what happened. So, sodium carbonate solution. Okay, approximately 3 centimeters cubed. Okay, so not too much again. Spread it about enough. And then hydrochloric acid, an equal volume, so again around 3 centimeters cubed. And they're going to start reacting straight away, so I'm going to need to do this quickly. Okay. Right, so on my delivery tube, okay, you can see that the lime water should begin to start turning cloudy, okay, because these two are reacting and carbon dioxide being produced.
It did show a few bubbles.
Yeah.
I don't know if they
I don't know.
managed to see, but
Yeah.
there were bubbles.
There are definitely bubbles there, okay, so which means that carbon dioxide was present, okay, but because of the fact this one you need to do it very quickly. If you don't do it quick enough, then carbon dioxide will escape and not be seen.
And you see, it is turning slightly cloudy.
It's slightly starting to change colour. I don't know if you guys can see it on the camera. It's quite hard to see, but it is definitely changing colour slightly. Okay, so there is little bits of carbon dioxide being produced, but as I said, this one needs to happen quickly. Otherwise, carbon dioxide is just going to escape out the top of the test tube.
We can repeat it if you want.
No, that's fine. So they know this test anyway.
Okay.
Yeah. Right. Okay, that was test 5. Okay, you guys should know this test anyway. Like I said, from GCSE anyway. So we're going to move on to test 6. Okay, so just give us 2 seconds again to set up. Right, okay guys, test 6, okay, there's 8 altogether, so we've got 3 left. Okay, this is test 6. This one is testing for sulfur ions in aqueous solution. Again, we've done the theory behind it, okay, so this is just showing you the practicalities of it. So, magnesium sulfate, okay, 1 centimetre cubed in a test tube. Okay, oh, and Kenny up. Okay. Okay, a bit more. That's enough. Right, magnesium sulfate, followed by an equal amount of hydrochloric acid. Okay, so 1 centimetre cubed again. And then you're going to add barium chloride to it as well. And again, the same amount, equal volume. And then just record the observations. So again, you should see white precipitate being formed. Okay, and again, you're adding barium chloride to magnesium sulfate. Okay, and you're adding it in the presence of hydrochloric acid. Again, producing barium sulfate. Okay, so it's white precipitate being formed again. Okay, remember this is the one that's using X-rays. Okay, right, that was test 6. Okay, and I'm going to just dispose of it. Okay, in the disposable beaker. Okay. And then give us again 1 minute to set up test 7.
Okay, test 7, darling, and 8, you will need to use the fume cupboard 4 and to probably talk a bit louder because the noise from the fume cupboard might.
Yeah, that's fine.
Who are you? Oh. You see, they wouldn't be able to do them 8 in 1 hour. You are working at a fast pace,
Yeah, I know.
and they don't. So,
They just want to slow.
test 7.
Do you want to do these ones?
No. I'm tired. Okay, these, so fume acid will sit in the test in the fume cupboard.
Yeah.
You need this is ammonia solution, aqueous, that is cold ammonia. You need the chloride, bromide, iodide of potassium solutions, nitric acid and silver nitrate. The instructions if you want to look here, and that's it. Thank you, Gabo.
Right, okay guys, so this time, okay, we're doing test 7, which is testing for halides in aqueous solution. So this is your ones that we've spoken about quite a lot. So you get a white, yellow and green precipitate, okay, depending on which halide you're using. This one needs to be done in the fume cupboard, okay, so Mr. is going to do the fume cupboard, okay. The reason is because we get some fumes, okay, that we want to try and get rid of, and we've also got the concentrated ammonia solution in the fume cupboard that we're going to be using a little later on. Okay, so in terms of dangerous chemicals, you put them in, you end up putting them in the fume cupboard. Okay, right, so first thing I'm going to do here is place 10 drops of potassium chloride, okay, in a clean test tube. Okay, so this one, potassium chloride. I get 10 drops. 3, 4, 5, 6, 7, 8, 9, 10. Okay, then add 5 drops of nitric acid solution and shake well.
Just lift it together with the lid. It's easier.
Right, 5 drops. 1, 3, 4, 5. Okay. Then there's to the solution, add another 10 drops of silver nitrate solution. So, silver nitrate.
It's okay, sir. We mix together is 5.
10 drops. 1, 2, 3, 4, 5.
Don't even need them.
Okay. So you see that's already turned white. Okay. Then I'm going to add excess of 2 moles decimal cube of ammonia solution and shake. Okay. excess, so not too much again, but okay. So you should be able to see that it's formed a white sort of solution, white precipitate being formed, and also like a cloudy solution. Okay. Right, then it says dispose of the test tube content, so I'll go to
in the sink.
sink.
This time we in the
Okay.
sink.
This time this gets disposed of in the sink. Okay, so depending on the instruction that you have, this time it says in the sink, so we can dispose of this in the sink. Okay. Right. Then it says to repeat steps A and B, but this time to add an excess of concentrated ammonia solution working in the fume cupboard. So we're going to work in the fume cupboard. Okay, well, I'm going to repeat steps A and B first. So add the potassium chloride and the nitric acid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then 5, 1, 2, 3, 4, 5. Okay, this time I'm going to use the concentrated ammonia solution, which is in the fume cupboard, and we're going to do the rest of it in the fume cupboard. Okay? So,
Sorry, I think you forgot
close.
the silver metal.
So, it says A, B. It says A, B.
I think the ammonia comes after the silver metal.
Here it doesn't be A, B.
Okay.
I'm sure of that. Look. Right, okay. So, concentrated ammonia solution. Okay, so okay, so we're going to have this in excess. Right, okay. So this time it's just produce a clear solution. Okay, no precipitate formed. Yeah? That's with concentrated ammonia solution. Right, that was for potassium chloride. We're going to do the same thing, okay, with potassium bromide, potassium iodide. So first we're going to add the normal ammonia solution, then we're going to add the concentrated one. Okay, just want you to observe and see what happens.
That was it.
Right. Yeah.
Let's take the pause for a second, please.
Okay. We're going to do potassium bromide and potassium iodide. Okay. So, 10 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10. Okay. Right, then we're going to add nitric acid. And dilute nitric acid as well. Okay, 5 drops. 1, 2, 3, 4, 5. Then our silver nitrate. Okay. So already that's become green colour. Okay. Then I'm going to add the ammonia, which is a normal 2 mol of ammonia. That makes sense. Okay, obviously you can see that a cream precipitate was formed, as you know, would have formed with bromide. Okay, so with chloride it was white, bromide is cream, and obviously you know what it's going to do with iodide, but we're going to do it anyway. Okay, and this again gets disposed of in the sink. Okay, and we'll do the same thing, okay, exact same thing with bromide, silver nitrate, nitric acid with concentrated ammonia, and just want you to see the difference between them. the concentrated ammonia to see what the difference is between adding dilute and concentrated. So you should be able to see that with the concentrated ammonia being added, the top of the solution has gone clear, and the bottom of the solution has stayed green. So that's the difference between dilute and concentrated ammonia. Concentrated ends up going back to sort of the solution, and then with the dilute one, dilute 2-molar one, again the less concentrated one, it will become say the precipitate. Again, this gets disposed of in the sink. And we're going to repeat the same thing with iodide. Okay, so first with dilute ammonia and then concentrated. I think you know what's going to happen anyway, but let me show you. 3, 4, 5, 6, 7, 8, 9, 10. Okay. 1, 2, 3, 4, 5. Silver nitrate, you know it's going to go yellow. Here this is dilute ammonia. Is that that's it? Okay, I'm doing it again. 1, well it tends to be an excess. Okay, so that's become gone yellow. Okay, you see that that's been produced. Right, we're going to get rid of this one and then do the same thing with iodide and concentrated ammonia. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Already changed the colour. Okay, again to yellow. And then concentrate the ammonia solution. And again you should see that the top okay, is becoming sort of a clear solution and the bottom stays as a precipitate. Okay? So you should make sure it's at the top. It's a bit of a cloudier colour this time, but it's still gone to a solution and the bottom says it's precipitate. Okay? So those were the testing for halide ions, okay, in an aqueous solution with both dilute and concentrated ammonia. Now, I don't know if we're going to have time for the last one. Let me just discuss it next and I'll come back.
So you are supposed to put that and that on the filter paper and hold it at the bottom of the filter. So if you want to follow the instructions as they said, you put a decontamination in the ramakin and keep the paper in it. What I will do, I will just drop a bit of the solution on top of this without having to put the bloody ramakin, but I will just follow this stuff. So this is the way it is. Hurry up a bit because you have to go to the Yes. Because you are going to use the sulfuric acid, that's why. So the glass after this.
Okay, it's year 7, so they'll probably be up late.
Okay, we'll be done in like 5 minutes.
Okay, I'll
You
get
can set up
down.
if you want.
No, I'll get down. I'll keep it there.
You
I
sure?
won't let it interrupt you.
Alright, well, I'll come down and
Yeah.
thank you then.
You see me that many times I can't the door.
Right, okay guys, final test. Okay, this one I need to wear gloves. Okay, because I'm using straight sulfuric acid. This one is tested for halide ions in solid salts, and then you're using concentrated sulfuric acid. Okay, so the test tube. We're going to put some potassium chloride. I know some of you were saying in the chat about it being camera not being great, but as I said, it's been recorded anyway, so you guys will be able to see it. Okay. Right, okay. So I'm going to slowly add 2 to 5 drops of concentrated sulfuric acid, and you need to record what happens. Okay. Then I'm going to test the gas that comes up with litmus paper, and then I'm going to do the same thing with bromide and iodide, but I'm going to use potassium dichromate instead. Okay, so just 2 to 5 drops, not a lot.
Move it in the bottom, please. Sure. Move it in the bottom. You need it again.
Just going to hold that over the top, and there's a gas that's been produced. Okay, and this time the blue litmus paper has gone red. Okay, also you can see where the reaction is going. Okay, right at the top, just top of the test. Okay, there's a very reactive reaction. Okay, and this is the one that came up in the test. Okay, in terms of redox reaction. Right, then it says repeat the experiment with potassium bromide. This time, gas produced, test the gas produced using a narrow strip of foil paper that can dip in 35 hydroxide. So, we do the same thing, but this time potassium bromide, and the same thing with potassium iodide. Okay. So,
Can you see if there is another lab free? And send us model.
okay. So, I'll do the same thing, but before I do, I need to get my filter paper and dip it, or add some drops of potassium dichromate. That's it. Okay, so the same thing. With the sulfuric acid, okay, add a few drops. Okay, a few drops, and then having my filter paper over the top. See what gas is produced. See what gas has been produced, and it should really come up. Yes, it's gone to like a yellow colour from the orange colour that it started with. So you should be able to see that yellow colour that you're produced. These are the redox reactions that came up in the test. Yellow should be going to be, you know what happens with oxide and oxide acid dichromate. Again, extreme much gas is being given off, and the reaction should be changed, the filter should be changed to green. Yeah? Right, so we're just going to do the last one really quickly. Right, last one. Potassium iodide. Okay, but this time the gas produced has to be on filter paper and then nitrate. So lead nitrate. Okay, and then concentrated sulfuric acid. Okay, I got a few drops. Okay, and then I'm going to hold the filter paper again. Sorry, it's not the filter paper, the lead nitrate. Over the top. And as the gas is produced, we can see again the colour change. Again, you can see the colour change going a bit darker. So you can see the colour has changed in the filter paper. Okay, and that's when the gas has been produced again. Okay, right, those are the 8 experiments. Okay, and essentially, yeah, those are the 8 experiments, and that's it, now we're done. You need to make sure you do the write-up for them, and yeah, that's it. I'll let you know everything what to do. Okay, right, thanks guys, see you later.